Welcome to today's daily video lesson. Today's topic is probability and statistics. As with all daily video lessons, feel free to pause the video and attempt the question on your own before seeing the solution. Here we have two histograms, and we're interested in the means of these datasets. Notice that dataset A has this outlier, and that dataset B is simply the set A, except for missing the outlier. That outlier is far above the rest of the data, which is going to drag the average up. Thus, the mean of dataset A is going to be greater than the mean of dataset B. Here, we are given 6 data points, and we're trying to add a 7th. We are comparing the mean and the median before and after this change. Right now, with an even number of data points, we look at the center 2 data points to evaluate what the median is. Since both of them are 54, then we start with a median of 54. Now, if we add the data point 60, we have 7 data points. The middle singular data point is going to be 54 as well, so the median actually does not change. Eliminate A, eliminate B. Now we want to know if the mean is going to increase or decrease. Considering 60 is greater than all the rest of the data points and is therefore an outlier up top, this is going to pull the mean up instead of down. Thus, the mean increases while the median stays the same. Range is an easier concept because the way we calculate the range of a dataset is we take the max value of the dataset and subtract the minimum value of the dataset. We have 5 ocean trenches. The shallowest one is 10,047, and the maximum depth is 11,033. Thus, the range is 11,033 minus 10,047, which is 986. Now we have a data set of 27 different numbers where the mean and median are 33. Note that since 27 is an odd number, we have an odd number of data points. So this median of 33 is actually the number 33 and not some sort of an average of 2 central measures. We are going to add 7 to every single number greater than the median. Here's our median 33, and anything to the right, we're going to add 7. And on the left, we're going to subtract 7. The median obviously does not change, so we eliminate that. The mean also does not change, because since this is symmetric, we add the 7, but then we subtract 7, add 7, subtract 7. There's no change to that overall sum, so both B and C are wrong. That leaves the standard deviation, which makes sense, because we are pushing the data points further away from the median, which is the central measure of tendency. Here's a probability question. We're interested in the probability of selecting a tree that is neither hickory nor oak, where T is representing our total number of trees, H is the hickory, and K is the oak. We don't want hickory and we don't want oak. So the desired trees, we take the total amount, we remove the hickories, and we remove the oaks because we don't want them. Whatever number this represents is the desired outcomes, the trees that are not hickories and the trees that are not oaks. The total number of trees is still T, so the probability of selecting a tree that is neither hickory nor oak is T minus H minus K over T.